All right, so last week we were talking about we started talking about the cerebrospinal fluid, and the cerebrospinal fluid being a clear fluid in the middle of your brain. It's housed by these ventricles. Ventricles are like these cavities in the middle of your brain. This is what the shape of the cavities look like. It also bathes the outside of the brain. It goes all the way down the center, so you have a hole in the middle of your spinal cord, and it goes all the way down the center of the middle of your spinal cord, and it goes all the way to the outside of your spinal cord, all the way down to your sacrum. So you can be connecting with the cerebrospinal fluid by doing a sacrum hold, for instance, when you're sitting, where your sacrum is. You're essentially, sitting on where the sacrum is making contact. The cerebrospinal fluid goes all the way down. Here we look at the third eye, not the third, the third ventricle, which I call the third eye. This is that midline structure here. It's got the pineal gland in front. It's got the hypothalamus, which is a major regulator for the hypothalamic pituitary gland, and adrenal axis for regulation of a lot of just our body's functions, and the pituitary, and then access to the pituitary gland here. How we see that this is a model of the ventricles. So this is in all of our brains. Essentially take this model, and this is the fluid filled spaces in the brain. And so it's just interesting from an anatomical perspective, right? We're talking about sort of models and symbols. Just if you were to design this, if you look at this as a model, it's just a very interesting anatomical creation. It's got two sort of shapes that go into each of the hemispheres. It connects in the middle. There's these projections back here that go all the way into the occipital lobe, where we process vision. It's just a very interesting shape. One of my colleagues who I work with, he actually did a 3D printer of the ventricles, and now he actually has it, and he meditates. He looks at the ventricles and he meditates on it, and he says, wow, it's very, very powerful. And so if you were to look, so everything in red here is the cerebrospinal fluid. The black or the dark here in the middle, this is your brain. Here's your spinal cord. You can see it going in the middle here of your spinal column. And then how the cerebrospinal fluid, there you go. There's Maxine has a model of it right there. Beautiful. Yeah, you can really get that 3D perspective when you're turning it. And this is essentially in the middle of our brain. So it's really beautiful. You can see the third ventricle there on Maxine's. Yeah, really beautiful. So here in red is all the cerebrospinal fluid. It comes all the way down. You can see how far it comes down. You can also see where the spinal cord ends right here. Typically, most people say it ends at about L2 or so, which is the lumbar vertebrae 2. But the cerebrospinal fluid goes all the way down to the sacrum. So you have this fluid that's just going all the way down to the sacrum. If you needed just a fluid pool in the middle of your brain, why not just have a cavity? Right, just one cavity. Why make it so intricate? It's just sort of something to ponder about, right? So if you were to look at it, this is essentially the pink here is our brain. We have cerebrospinal fluid in the middle and on the outside. So we're literally, our brain and our whole central nervous system is like a buoy in this fluid going up and down. And we talked a little bit about the weight of our brain without the fluid. If you take it out, it's about 1,500 grams. And with the fluid, it comes down to about 25 grams. 25 grams, imagine that. So here I am bouncing around with the fluid, right? We talked about the fluids, and we did of where these come from, and also embryologically, just how much we are informed by fluids, how much fluids are bathing the cells that become the embryo. Here we have the amniotic fluid being the most potent, that becomes then the cerebrospinal fluid and actually informing. Here's the embryo, this black thing. This is what we become, and it's initially a two-layered sheet that then becomes a 3-layered sheet that then goes through a process of differentiation to become the embryo. Okay, and this is that process where essentially you're this sheet, and here amniotic fluid is on the outside, and you actually go. It's called an invagination process. The cells actually invaginate, create this indentation here, and then these cells up here fuse. And then the cells around it come around and create a separate entity here. This is the neural tube. This is what's going to give rise to your spinal cord, your central nervous system. And then in the middle here is like a hollow donut cavity. This is where the amniotic fluid that was bathing the top becomes now the cerebrospinal fluid. All right. So when it's encased in this tube, now the center of that is the cerebrospinal fluid, and you can imagine more of it as the brain develops up front, that you have these larger cavities and more cells going to that area. And this is essentially, I've shown these images before, but this is a scanning electron microscope image, and we are sitting or looking from the vantage point of the amniotic fluid. Here you see the folding, the indentation here occurring, the folding. Here the folds come up. And then if you see the folds come up, so we're still at the vantage point of the amniotic fluid. Here the folds come up. You see them starting to fuse here at 16S. And then, so here you still have the bathing of the amniotic fluid and the cerebrospinal fluid, right? Because it hasn't completely fused. So we are in the amniotic fluid. We can go into the cerebrospinal fluid. So there's this mixing of the fluid still. And then at 18S, it's completely fused, and this is the embryo. So now you have this differentiation that has occurred from the amniotic fluid into the cerebrospinal fluid. And now the cerebrospinal fluid is called the cerebrospinal fluid. It's in the middle of this cavity, which is going to become all your brain and your spinal cord and your whole central nervous system, essentially, right? So if you can imagine that, I call the cerebrospinal fluid, like there's a homeopathic quantity of amniotic fluid in our cerebrospinal fluid, because it just constantly gets diluted. But there's that energetic connection through our cerebrospinal fluid to the amniotic fluid, and therefore from the amniotic fluid to those that first cell layer that was laid down. And so in those meditations or visualizations, you can actually go back all the way back to those cell layers, which can be quite fascinating. All right, so this is what it looks like. So this is that tube. This is all in here. There's cerebrospinal fluid. It continues to develop. This is the forebrain that develops, that becomes our brain here. And you can see this is color depicted, so you can see how large this area of the neural tube becomes to become our brain. And throughout this whole process, remember, there's fluid in the middle here that's bathing the cells and the tissues and really informing it. All right, so here you are as a fertilized egg. Takes 7 days to go down the fallopian tube. We've covered all this in the embryology lectures. You implant. There's a relationship with that implantation with the wound. There's an acceptance. There is a big yes, right? There's a big yes from life, right? Yes. It implants. Now the embryo says, yes, let's keep going. I have the nutrients, and you start to develop, and here you are. And this is, after all this, right? These are all the cells that are going into the womb, creating the placenta. Out of all this, where do you come? You come from this two-celled layer sheet right here in the middle, right? With the amniotic fluid being on top and the yolk sac here. And this is the chorionic fluid here that gets displaced as this grows bigger and bigger. You displace the chorionic fluid, and now you have the embryo that's essentially in the amniotic fluid. And from this amniotic fluid, you create the cerebrospinal fluid, which is this red fluid here. Great. So we're going to talk about a little bit about the role, just for your understanding, so we're all on the same page. Okay, fascinating study that was done in 2016 is they actually looked at the evolution of the cells that in a vertebrate, us, right, make contact with the cerebrospinal fluid. So those are those cells that are on that neural tube that contact the cerebrospinal fluid. Well, evolutionarily, what they determined is that those cells are actually very similar to cells that are found in like on the starfish. And those cells are the same cells that are actually contacting the seawater. As the starfish or these species evolve, and you get sea worms, for instance. So a sea worm has an internal fluid environment and an external fluid environment. But the fluid environment of the internal is essentially the sea worm is swallowing the seawater. The cells that are contacting the inside of the body plan of the sea worm that's contacting with the seawater that the worms are swallowing are evolutionarily related to the same cells that the starfish is making contact with the seawater. And evolutionarily, these cells that are making contact with the seawater are the same cells that are actually making contact with the cerebrospinal fluid in us today. So if you think about the function just from an evolutionarily perspective, right? What was that function of that? Well, it's to actually monitor the seawater. It's to monitor the influx of nutrients or chemicals or toxins or vibrations or whatever it might be from the seawater. As the body plan evolves and starts to become enclosed, those cells are still monitoring for instance, in the worm, they're still monitoring the seawater. Now the worm has to swallow it, right? So the worm swallows the seawater, but it's still monitoring the seawater. And I can guarantee you that information was being collected by these cells from the external world, from the seawater, and being transmitted to the organism. Right? From these cells, from the interaction of these cells and the fluid that was all around them. Okay? These cells are still present in us today, evolutionarily. They are now perceiving and sensing the cerebrospinal fluid. Okay? So even evolutionarily, the cells that are making contact with the cerebrospinal fluid today, we're still gathering information from the fluid environment. And what sort of information does the fluid environment have? Well, the fluid environment has information based on flow, right? Movement, vibration, flux, light, sound, still a vibration, but also all the molecules that are in the water. Right, so you have your whatever it might be, the amount of electrolytes that are present. Right, if it senses a toxin from an intruder or something like that, or if it's going towards food, so nutrients and things like that. Right, so we have those same cells. So just kind of like keep that in mind, that these cells are evolutionarily, we're perceiving the external environment in terms of what's coming in. Okay, so if you look at the developing brain, for instance, in a human, this is the developing brain of eight weeks in development, and this is the developing brain here, and this is a structure called the choroid plexus, which makes the cerebrospinal fluid, and that's a very large structure. It's a very large structure in the brain to make a lot of fluid. And here, if it makes a lot of fluid, everything that you see in blue, in light blue there, is cerebrospinal fluid. So all this fluid is doing is really informing the brain and helping it develop, survive. It's providing very important growth factors to it. It's guiding it in terms of development, et cetera, et cetera. And this is all research that has been done over the years. Okay. What's awesome is that more and more people have been looking into the benefits of the cerebrospinal fluid. And if you haven't seen this videos, it is a beautiful video done out of Boston University that was published in I believe it was Science in 2019 on the showing CSF pulsations that occur during sleep. So there's a big question of like, well, what is the cerebrospinal fluid doing? Right? Everyone just sort of thought it was a buffer, that it just, provided a few nutrients, but that it was mostly a buffer, creating that buoyancy, so that, if we got hit in the head, we'd have a little bit of a buffering system between our brain and the skull. Well, this is the cool part. So during sleep, when we sleep, there's actually a coupling of brain waves and blood flow and cerebrospinal fluid movement. So there is a change in the way our neurons are activated. During sleep, there's a slowing of the brain waves. The slowing of the brain waves leads to flow of blood out of the brain, and then a pulsation of cerebrospinal fluid into the brain. So it's slowing of the brain waves. Blood comes out of the brain, pulsation of CSF into the brain. Slowing of the brain waves. Blood comes out of the brain, pulsation of CSF into the brain, right? And I have a video here. So if you haven't seen this to me is probably one of the coolest. All right, so here you're gonna see the red is flow out, and that's the blood. And then you're gonna see blue, which is flow in, and that's the cerebrospinal fluid. It's 16 seconds. Blood flowing out, cerebrospinal fluid pulsating in. Blood flowing out, pulse of CSF. Blood flowing out, pulse of CSF. All right, see that? Blood flowing out, pulse of CSF in. Blood flowing out, pulse of CSF in. Blood flowing out, pulse of CSF in. So imagine, right, this pulsation. Okay. All right. Amazing. All right. If you haven't seen that video, it's very, been validated now a few times. So when you're sleeping, okay. So that was so this research really started in about 2013 when they discovered this movement of the cerebrospinal fluid into the brain, through the brain. And essentially, all the media was like, our brain is washed by the cerebrospinal fluid when we sleep. And that's why sleep is so important, because it creates a moment in time when our brain neurons are relaxing, when the blood can flow out of the brain, when we're not metabolizing so much, and then the cerebrospinal fluid can come in. And what they've shown is that the brain tissue actually opens up, and so the fluid can now flow from those ventricles that I showed you into the brain tissue itself, and essentially clean up any toxins that occur throughout the day, just from us thinking and being alive. Okay. So that was one of the first sort of, explanations of what the fluid does, or why sleep is important, and how the fluid is important in that process. So kind of cool that the cerebrospinal fluid is involved in that. Okay. And now, all right, so we see that. So essentially what they say is there's a cleansing process that occurs. What are some of the roles that we know? Okay, so it transports nutrients and hormones. It regulates circadian rhythm. It regulates appetite. It provides guiding cues for cell migration. So it actually helps in cell migration. It instructs stem cells to proliferate or differentiate. It creates an ionic balance. Again, it's actually providing an ionic balance. Like, those are all the electrolytes that need to be balanced for our tissues to work. It eliminates waste, and then it definitely supports and protects the nervous system and creates a buoyancy. Okay. But it's also a fluid. So we're going to get into this a little bit later when we start talking about water. And so just in terms of like, thinking about what the fluid does. So this is what the third ventricle, or this is what the ventricles look like if you're facing somebody. So this brain is looking at you. This brain is looking to the left, right? So this is what the side view looks like. If you have a model like Maxine does, it can really help in that. Okay. And again, those walls of the cells that are bathing the cerebrospinal fluid have various receptors on them. And those receptors include photoreceptors to perceive light, chemoreceptors to perceive growth factors, ions, and hormones, and mechanoreceptors that perceive flow, movement, and vibration. Isn't it fascinating that we have these cells that are actually perceiving all this stuff from the fluid, light and growth factors and flow and movement and vibration? Okay, so irregardless of anything beyond this, the cerebrospinal fluid is very important in terms of transmitting information. It just is. It's transmitting information from the amount of light that we're exposed to, from the growth factors that are actually secreted into the cerebrospinal fluid, from hormones that are secreted into the cerebrospinal fluid, as well as from flow and movement of the fluid itself and vibrations. All right. So just really, really cool things. Somebody asked about dreams. Well, melatonin is released by the pineal gland into the cerebrospinal fluid itself, and then from the cerebrospinal fluid, it gets dispersed throughout the whole brain. We need melatonin. It's important for circadian rhythm. It's also a powerful antioxidant. DMT, dimethyltryptamine, which is a potent hallucinogenic, has been found in the pineal gland and also released into the cerebrospinal fluid. And so studies are ongoing in terms of what is the role of DMT in the pineal gland or DMT in the cerebrospinal fluid. It can definitely produce great hallucinations. There's a lot of research that have looked at increase in DMT production at time of death, and those studies are really ongoing. And so what I want to talk about today is more about the movement, and we'll see how much we actually. Okay, so the importance here is what, to me, sort of what causes the cerebrospinal fluid to move, and we see that sleep does. Right, but sleep is just an altered sense of our nervous system. It's in my view, it's sort of an altered sense of it's an altered state of consciousness in essence. And so, do you need to be asleep for the CSF to move? And I would argue that any activity that is mostly parasympathetically driven, any sort of rest and relaxation. So this is where the you can probably get the CSF to move and pulsate during massage, during an osteopathic cranial session, during a craniosacral session, whatever it might be. Anything that causes you to go into a state of sort of great rest and relaxation. A meditation could cause your cerebrospinal to move. But what we also know is that there's a lot of research that has been done. So the heartbeat can cause the cerebrospinal fluid to move. And movement, things like yoga, singing, dance, any vibrations, sound can cause the cerebrospinal fluid to move. But one of the great movers of the cerebrospinal fluid is our breath. And this is actually very powerful research that has been done. And essentially, I'll just show this taken from an article, that inspiration, right? And this is where we're going to kind of go into this week and next. Inspiration causes the cerebrospinal fluid to move towards the brain. Take a deep inhale. When you do that at all levels, so this is a study that actually looked at all levels of the spine, from cervical vertebrae 3 all the way down to lumbar vertebrae 4. And you can see any place when you inspire, you're drawing the cerebrospinal fluid up towards your brain. When you expire, from about T6 or T4 onwards, you're actually pushing the cerebrospinal fluid down. So, imagine that you are in a bathtub, right? And it's totally still, okay? Imagine you're in a bathtub and it's totally still. There's a few ways, and let's say the warm water is by your feet. How could you get the warm water to come up towards your head? Well, you can actually go to your feet and move the warm water towards you, right? So that would be like an inspiration, okay? So inspire, move the warm water towards you. So the warm water is like the cerebrospinal fluid, okay? So you can go down to your feet with your hands and just sort of move the water towards you. Or you could stay at your head or your arms. And have you ever pushed a wave away from you and it hits the back of the tub? And then what happens to that wave? It comes back towards you, right? So let's say you can't get to your feet. My arms are this small, right? Whatever it might be. But I can do this, right? I can push it. And what happens? I'm creating a wave now that goes down. It hits the bathtub wall. And then that wave hits the bathtub wall and comes down. So imagine now doing this with your breath. Okay, you inhale, bring the spinal fluid up. Exhale, from your thoracic vertebra down, you're actually pushing the cerebrospinal fluid into your sacrum, where the kundalini is resting. It goes into the sacrum, and then what do you do in your next inhale? You're actually actively then bringing it up. Exhale, pushing it down from your thoracic vertebra down to your sacrum. It goes in. Imagine it taking all the energy from your sacrum and bringing it up on your next inhale. Down, up, down, up, down, up. And you're creating like a little pump, right? With your breath. This is the coolest thing in the world. You're actively moving fluid in the middle of your in the middle of your central nervous system with a coordinated breath movement. Okay? Going down into the sacrum. Maybe it's been stagnant in the sacrum. How can you activate it? How can you bring any fluid? What do you want when a river is flowing? Do you want the river to be dammed? What happens when it's dammed? Then the algae starts to form, and all these microbes and stuff like that. No, the river's flowing. It's clear, right? Let's continue. Let's actively flow this river and just see what happens. This then brings in the concept, which I'm not going to get into because it's covered by other people and I've been interviewed on it. But in yogic practices where there's bandhas, where you can lock the bandhas. So imagine you bring the energy up. You're actively contracting the perineal floor, and we're gonna put this all together. It's just gonna take a few weeks, okay? But you're actively activating the perineal floor, right? With the breath. So imagine perineal floor activation. You're squeezing physically with the breath. You're bringing this up, right? And then you release, breathe down, exhale. Why? Because you want to release the perineal floor, create an opening, breathe down, have the fluid go down into the sacrum, bring it up, and close the perineal floor. Then you get into all the bandhas as they come up, and actually learning how to elevate the energies and hold them. Elevate the energies and hold them. Elevate the energies and hold them. Okay? So that's a little bit of like the anatomy and physiology of actually what's happening when we're breathing, right? It's like the coolest thing in the world. And all I'm showing you are some slides of research that has been done, which is why I love it. Now, let me show you. Okay. So this is a 3D image of how much our brain moves. This is enhanced. This is an enhanced image of an MRI. All right. So this is our brain stem. This is our cerebellum. This is the fourth ventricle. This is that same area that we just saw that was really lighting up with the sleep. It's an area that can be well visualized. Everything that you see in white is here is cerebrospinal fluid. All right, so you see how it's really just bathing almost everything. We don't go up into the top of the head, but you can see. All right, so this is the movement. It's an enhanced view, but imagine, right, fluid in a small space doesn't need much to be able to move and vibrate. So imagine taking this at the molecular level, right? And this is what this is depicting. So watch the movement. So this is simply the movement of your brain, and hence the cerebrospinal fluid, with our heartbeat. Look at that pump that is even being created here in the front. So imagine with every heartbeat, you're not doing anything. So this is the unamplified, this is the amplified. On a molecular fluid level, we are more reacting to the amplified version. Okay? Because these are creating vibrations in the brain. Okay? Right? With every heartbeat. How would you like, now when you see this, wow, do you want to train your heartbeat how to beat? Like doing maybe some breathing exercises that can bring in increased heart rate variability, so that we're seeing a nice flow of heart rate. It's just something to sort of, think about. That's the movement of the brain with just the heart. Okay. So imagine how much you could actually influence that with now bringing in a coordinated breath, right?
Yeah, amazing.
So, right. So excellent. So there's a recent study that actually looked at deep diaphragmatic breathing, and how much and every inspiration leads to a potent influx of cerebrospinal fluid into your brain. All right. So now I'll show you, various ways that just because it's fun. You guys like beatbox? So this is technically looking at the tongue and the mouth, but right behind here is the spinal cord here. So you can just see this is somebody doing beatbox. This is from the Max Planck Institute. Look at the movement in the brain back here. Look at that pulsation that he's creating by his vocalization. All right, this is from the Max Planck Institute. All right, this is freaking cool. Okay, that is all right. And then here's another one. Last but not least. All right, so this is an individual singing.
My name's Tyler Ross. I'm a singer, voice teacher, and vocalogist in New York City. And using the magic of MRI technology, I want to show you what it looks like inside my head and neck while I'm singing. But first, let me warm up on a lip trill.
So this is his brainstem, and here's his cerebrospinal fluid.
What about a raspberry?
Look how much vibration we can actually cause in our brain by doing that.
Weird, right? Want to see that on an ooh vowel? Now, before I go any further, let's try to figure out what it is we're actually seeing here. Let's go lips, tongue. This difficult to control piece of anatomy is called the velum or the soft palate. You can think of it as the nose gate. It opens and closes, controlling the flow of air and sound up into the nasal cavity. In most people, the velum is opening and closing constantly when we speak and sing, and we're barely even aware of it.
So he shows all the anatomy of the voice. You can see all the vibrations actually occurring in the brainstem, and all that's going to do is translate into the fluid, and you can see the impact of that through the fluid, whether it's using vibration again, whether it's using breath, whether it's from your heartbeat or whatever it might be, right? So your breath can actively, so from this perspective, all right, looking at and really just sort of taking it in and saying, wow, my breath, as well as all these other things, right? Sleep and my heartbeat and sounds and vocalizations that are being created are really affecting my anatomy. They're really affecting the structures, and they're affecting the fluids, right, in real time. And so imagine, right, just as I described, okay, this ability that even if, right, take away anything that this fluid might do esoterically, or from, spirit into form, or from a differentiated to a less differentiated state, take all that away, right, and just look at it purely scientific, medically, anatomically, right? This fluid is very important in cleaning toxins in our brain, in being able to go from the ventricles, from these cavities, into the brain tissue and cleaning out the toxins that build up, into providing hormones and growth factors to the developing brain, and even continuously to our brain today. Nutrients and buffers, and perceiving the flow of the fluid movement in terms of health and vibrancy. And that we can actively control this movement. We can focus on improved sleep, right? Hey, you know what? I'm going to really try to get some 2 or 3 hours of good sleep tonight, or 4 or 5 hours, or whatever it might be. Right. But also with the activities of your daily life, with being able to breathe, with taking some moments and saying, you know what, I'm going to actively choose to move this fluid. I mean, you have the choice of like doing a practice where you can move this fluid similarly to how you would if you had hot water in a bath and you just wanted to spread it out a little bit more evenly. You either bring it up or you can push it down, or you do a combination of those, right? And so that to me is really the beauty. And I guarantee you, if you continue to follow this research, it's going to explode. The combination of, for instance, breath modulating the movement of the fluid, and from the movement of the fluid, looking at how the breath may be actually creating a resonance frequency in the fluid that is then able to inform the brain tissues. And then looking at how are the frequencies that are generated by various breathing techniques informing the tissues through the vibrations of the fluid that are then creating and expressing and releasing neurotransmitters, including things like DMT that is endogenous to us, or endocannabinoids, or creating a resonance frequency within the brain because we are actually focusing on modulating the movement of the fluids that leads to altered states of consciousness that people are looking at directly through the breath and integrating areas of the brain. All right. People are starting to do research on this, and they're starting to look at the mechanics of not only breath work, but also, altered states of consciousness from breath work, and looking at different regions of the brain that are activated. It's really hard to do studies on the cerebrospinal fluid because it's a fluid. And so like you see those micro resonant frequencies are difficult to measure. And so we're still in the realm of whole tissue. What are the areas of the brain that are activated? But slowly, as the technology gets more and more refined to be able to see these and to be able to study them, it's just it's almost like we can see the future. It's like this is really where it's going to go. But it comes back to, in my opinion, really doing the resource practice, right? Finding your resource, because as you're entering these new dimensions or these new states, there might be episodes where you might feel a little lost. You might feel ungrounded. You might feel disembodied, and that's part of that differentiation process. And to learn how to be comfortable with that by really resourcing, grounding yourself, doing all the practices that we've talked about and led up to this information, and going from there. But that's sort of the importance of, it's like, oh, all of a sudden a thought emerges or some emotion comes up, and being able to come back to your resource, go into that emotion, doing any one of the emotional processing practices. If an unpleasant sensation arises, what do we do with it? How do we find resource in that? And then how do we investigate that? How do we choose to, what is it that arose, and how do we then choose to, does it come up again? Right? If it comes up again, it's an energy pattern that's then coming through. How do we then start to have a relationship with that, or even open up to that? And that's that titration process. Right? So that's why this is all so integrated and so important. And for today, I think that'll be enough. And then really kind of going into the practice next week with and it'll be quite a dynamic practice, let's say. But just sort of, what I would do is really hone your skills that you've practiced up until now. Really practice the resonance and really practice the resourcing, really practice the titration. And now that you know this, you can start to even investigate yourself of, what do I feel when I, and the easiest thing to do, which is where we'll start next week, is essentially, bringing your attention to your third ventricle and just breathe, seeing what you notice. And that's it. And then come back. That's your homework. That's your homework. And literally, like, what do you notice? Right? What do you notice? Because I don't want to put things into your, I don't want to put things into your conscious, like just doing that. So bringing your attention, right? So it's almost like, it's like for the first, how many practices we had, I always had you do a downward gaze. Now it's an upward and inward gaze, right? So we shifted the gaze, if that's comfortable for you. It's a shifting gaze, and it's almost as if your eyes are like cross-eyed looking in like this, right? As opposed to, I used to have you kind of look down as if you're kind of gazing off onto the horizon, like you're right down. Now it's like this, in. You're literally turning your vision up and into the middle. Can you do that? First of all, like it's like your third eye, but it's not external, it's in the middle. Know that this space in your body is filled with fluid. It is making contact with the pineal gland, your hypothalamus. It's got a connection to the pituitary. All huge, major brain areas for coordination of so many different important functions. And then just breathe.